now, we talked about correlation before, and we looked at a scatter plot. Like, let's take a look at the one that I just had up. Not with R, but just looking at the data, how would you describe that? Weak positive? Yeah. Okay. So that's what I mean by telling us the strength and direction of the association. And so far, all we've done is we've just eyeballed it. We've looked and we said, hey, if it's more spread out and then it's going on an angle, it would be weak. If it's going up, we call that positive. If it's going down, we call that negative. Noli move to the front. If we saw a blob of points anywhere, I don't care, just so you're not next to Aubrey. Okay. If we just see a big blob of points, what does that mean? What do we call that? No association. Okay. But today, what I'm going to give you, because we just were looking, sometimes we saw, some people said, hey, I think that's weak positive, and some people said it's none. So what I'm going to give you next is a chart, so it's a little bit more specific. And so we're going to look at our value on our calculator, and we're going to use the following chart. So let's take a look. And what I would is this chart, please. So what we have in the middle is a 0. The closer something is to 0, that's the closer there is to no association. If something is between 0 and 0.5, what do we call that? Positive. It's all positive, but we call maybe 0 to 0.5, we would call that weak. And then something that was 0.5 to 1, we would call that strong. And maybe we could even add some more words. You know, if it was like 0.99, you might say very strong. And everything that's a positive number is positive. What does that mean about the data? What is it doing? It's going up or going down? Going up. On the other side, we see a negative 0.5. And so something that was between 0 and negative 0.5 is going to be weak, moving its way to strong. If it's all the way to -1, that would be perfect. But anything that's negative is a negative correlation, meaning the data is going to the right and going down. Okay, so now we're going to do one more example. It's going to be good to remind us how to do all of those things we've already done, but really what we're going to look at is the correlation here, okay? So let's take a look at that example. Says Kendra likes to watch crime scene investigation shows on television. She watched a show where investigators used a shoe print to help identify a suspect in a case. She wondered if it is really possible to predict how tall someone is from a shoe print. To investigate, she collected data on shoe length in inches and height in inches from 10 adult women. Her data appears in the table in the scatter plot. It's the table and the scatter plot below. What we're going to do is take a look. It looks like she already put the data in order for us, which is nice, meaning she put the smallest shoe length to the largest. Just by taking a look in general, does it look like there is a relationship? Does it? It looks like probably what, a positive or negative relationship? Okay, let's check our R and see what happens. So if you have your graphing calculator, let's take it out. We're going to put shoe length into our list 1. And we're going to put height in our list 2. Okay, so I have my data in my list. I'm going to answer question A. I'm going to write yes. And to back it up, I'm going to just do zoom 9 because that's going to show me my, my points. So we would say yes. It looks like a positive relationship. Okay, so now that I have the scatter plot, do you guys have the scatter plot up? If you don't, go to zoom 9 and get it to show up, please. Okay, so now we're going to use the statistical features of your calculator. We did a scatter plot. Let's do a linear function. That's the line of regression. Who remembers without looking already? How do I get the line of regression? Stat, good. Calc. 4. Would you do that, please? And confirm that you get the same thing as me. So y equals 3.147x plus 32.679. I'm going to round to 3 decimal places. And I'm going to write down R. R equals 0.906. Look at your correlation chart from above. What region does that fall into? Positive and what else? Strong. So between 0.5 and 1 would be strong. The closer it gets to 1, the stronger it gets. So this shows us there is strong positive correlation. And what that really means is as the shoe length gets bigger, what happens to the height? They are taller. So they are linked, that the larger shoe size you wear, the taller you would be. Suppose that these 12 women can be considered a representative of adult women in general. Now, there's only 12 of them, okay, so that's a little bit of a stretch, but based on the linear regression, what would you predict for the height of a woman whose shoe length is 10.5 inches? Go up and look above. Was shoe length X or was shoe length Y? X. So where should I put 10.5 then in this equation? X. Here we go. Show your work. 3.147 times 10.5 plus 32.679. I'm going to be consistent with my table, and I'm going to round to the nearest inch because all of these were rounded to the nearest inch. So here we go. I'm going to round that to 66 inches. What is this called? Is it interpolation or extrapolation? Can somebody explain to me why? Yep, 10.5 would fall in the range from in between 8.9 and 11.8 in the data set. Good. All right. This is still interpolation. Let's do an extrapolation one, okay? Let's change that 11.5 to 12. What would you predict for the height of a woman whose shoe length was 12 inches? Okay, and I already gave it away, but I wanted to show one that was extrapolation and why. So now I plug 12 in for X. And I get 70 inches. And if I chose 12, that would be extrapolation. So the reason why is because what's the highest X value you see in the table? The highest X value, 11.8. And what did I have you put in? 12. 12 is outside of the highest data value. I also could do something below 8.9. That would also be considered extrapolation. Okay. Some of you guys have been struggling with this, so this is not correlation, but it's good that we're doing this. What is the slope in this case? What number? This was my equation for my line, guys. Which one was the slope and what's the y-intercept? Okay, so what the slope means is it is the change in the y over the change in the x. So what this means is for every 1 inch change in, what's the x again? Shoe length. There is a 3.147, you can round it if you want, inch change in height. So the slope is just telling how does your y change for every x change. So for every 1 inch change in shoe length, there is a 3.147 inch change in the height. Okay. F, does it make sense to interpret the y-intercept in this context? So the y-intercept was 32.679. Can somebody tell me what that would stand for? That would stand for a height when the shoe length was what? 0. Does that make any sense? No. So does it make sense to interpret the y-intercept? No. Because it would be the height when shoe length is 0. It would be the height when shoe length is 0. Okay. Didn't we do G already? Yep, because I changed D. And cross out G.